most information that's transported nowadays is packet Ethernet protocol. So basically the information is transported in little packets of a certain data size. Each packet has an address on it. It tells you who sent it, where it wanted to go to, and in what order it was sent. The routers on all the networks are intelligent. They can route it quickly to get it from A to B and in the right order. And it all happens, virtually at the speed of light. I mean, it's very, very, very quick.
So the internet is built around a model where there's a large collection of networks, and networks can be anything that runs internet packets. Can be an operator like KPN, where all the households of the Netherlands connect behind. Or it can be a network from a large content provider like Google that serves answers to questions. Or it can be a large network like Netflix that serves you videos. And to make the internet work, somewhere all these networks need to interconnect. So an internet exchange is one of the forums where these interconnections happen. And that's quite a lot. There's like 50,000 identifiable networks in the internet. On M6 are all the major internet companies that are around. So there's 700 total, and that includes all the big content parties. We have many events where we meet all these people that are involved in what we call peering. Peering is the relationships between networks, the relationship to exchange traffic between each other. I don't know how to say it short. It's just not that simple. And there's not that many people that actually fully understand it. And there's maybe like 500 to 1,000 people worldwide that are very familiar with the whole interconnection thing specifically. Very few people actually realize that the internet is not like one thing that can be managed, but it's all these different networks that each manage themselves. But then you have this need for this couple of hundred to 1,000 people that actually make it happen, that all these networks connect with each other to make it the internet.
Historically, it's been about the network. From the beginning, data centers were typically aggregated around these switch points, which quite frankly were the very switch points where we can imagine in the 20s and 30s you had telephone operators clicking and pulling and connecting phone calls. Well, those were physically located near population centers. That phase of data center site selection was 100% based on network. The problem that was identified was there's disadvantages towards operating a factory very close to population centers. It becomes very expensive, but things are changing. And business is starting to become interested in not only how much energy am I using today for my data center footprint, for my data footprint, but also the core elements that drive the cost of that data center footprint. If we boil it down, it ends up being the energy that becomes an inhibiting factor to us being able to grow.
I mean, there will be waste heat when you use data centers and all the equipment we use. It needs to go somewhere. So you do it in the most efficient place, which at the moment, with the technology we have, is up north.
So when you look at the cloud, if you're putting a cloud in a country like Iceland, you have to look at a few things. Do I get enough electricity for a long term? What about the telecommunication? Will I get enough capacity for the next 10 years? How is security? what about latency? How far are we too far away from the customer? You know? So there are three things: capacity, latency, and security or availability. And then the fourth factor, what will it cost? It's a volume game, we can say. The internet is a volume game.
At the core of what we provide to our customers is energy, it's power.
We are looking at the market where you need to do some heavy computations, need a lot of energy.
One of the reasons that Vern came to Iceland is because there's a huge amount of energy that's available here. Our energy sources are geothermal, they're hydro, they're wind. We don't rely on carbon fuels to be able to continue and perpetuate the advancements of the cloud.
We're always limited by the technology we have available. It's in everybody's interest to look for new technology to do this more efficient. Every bit of waste heat that there is a loss for a company that runs a data center. So there's a big incentive to go further.
There's a bit of push-pull, there's a bit of cynicism in this, but the reality is, if we can eke out even 1% better efficiency, we're going to save money for our shareholders, we're going to save money for our customers, we're going to use less energy.
Cloud has reaches which go way beyond just what we see at the peripheral. Sure, there's Facebook and Google and email and phone applications and the way that we communicate with other people, but at the back end, the major players are the ones who connect the cloud to the energy itself.